So now we're at the point of section 1.3, drawing conclusions from studies. Now what this is going to look at a little more is I'll be looking at some more terms of what you need to think about where your conclusions are going to go, and are those conclusions going to be valid or not. So far, we studied 1.1, we talked about the types of data, some basic terms for data collecting, and 1.2 showed you how to organize that data. We looked at a double proportion bar graph of how to look at, okay, here's categorical data, where do things, which one's higher, which one's lower. For the dot plot, we saw how are things consistent, are they inconsistent, where does it tend to be, where does our values tend to fall. Okay? So now looking at some more conclusions, if we're looking at a dot plot, we say, okay, this tends to be a high value, what population can we generalize it to? Okay, so the first we're going to look at is population versus sample. Okay? Now population, this is going to be the entire group of interest. It's every observational unit that fits in our group of interest here. Okay? So population is very big. I'm sure by now if you've talked about population a little bit, how it's everyone, it's everything that you're looking at. Now, taking a study and trying to do it with the entire population is difficult. Time, money, it's just very hard to be able to survey or observe every single piece of your population. So what we do is we take a sample, a small part of the population, use to collect data so you can learn about the population. Right? Think of it like this. If you're cooking a big pot of soup, you don't need to take every little bit of the soup and taste it to see if it's good or not. You can take just a spoonful. As long as that spoonful represents the entire pot of soup, you are okay. You can say if that soup is going to be good or bad. You can say if that soup needs salt or whatever other ingredients. Okay? As long as your sample represents. And that's an important part here. Picking a sample must be done carefully so the sample is representative of the population. Okay? If you're looking at that pot of soup and you don't have everything mixed in, if some of the ingredients are only at the bottom and not the top, and you take one spoonful, that is not going to be representative of the population, your pot of soup. If you're looking at a high school has 9th, 10th, 11th, and 12th graders. Usually they're split up pretty proportionally where each group's going to be about 25% of your high school. Well, if you take a sample that is 80% freshmen, 10% sophomores, 10% juniors, and no seniors, well, does that sample actually represent your high school? Probably not. Freshmen and seniors have some different viewpoints on things. Okay? Actually, many things. There's a lot changing from freshman to senior year. You would want your sample to be just as proportional as your regular high school is. Okay? And your sample size. Okay? N is the universal symbol for sample size. So anytime you see little n equals 500, little n equals 20, that's telling you what your sample size is. Okay? A lot of people get hung up on sample size. Okay? As long as your population or your sample is taken randomly and it represents all the pieces of your population, having a huge sample is not always as important as long as your sampling method is making sure every piece of the population is represented proportionally. It is as close to the population as you can get. Right? A truckload of apples is being dropped off at a farm from an orchard. The apples are in 135 large buckets. Before the farm takes the apples, they are inspected to see if they are up to standard. This is done by taking 3 random buckets to inspect those apples. If those 3 buckets are good, the whole truckload is taken. Okay, so I want to ask you, what is the sample, what is the population, and is this a good sample compared to the population? Okay, so I'm asking you, the sample. Our sample here is going to be the 3 large buckets. And it is important to note, they were randomly selected, okay, taking 3 random buckets to inspect them. And that is important because since they are random from the truck, okay, I would say that they're probably pretty good. They're a mixture of the entire orchard. Okay? The population in this case, the population we're looking at is the truckload. Okay? And try and be as detailed as possible when you're talking about the population. Don't just say apples. Okay? Because if you just say apples, that means we're talking about all the apples in the world. If you say that particular truckload of apples, that's the population that we're looking at. Because they check those 3 buckets, they accept the whole truckload. They don't accept, okay, you can just keep bringing all the apples from the orchard. They're looking at just that truckload. And the last part, is this a good sample compared to the population? Okay? I would say yes. And it's because of those random buckets. So let's think about the process here. Okay? If you're driving through an orchard and you're filling up buckets and putting them in the truck, usually you're going to take those first couple buckets and put them at the very back. So as you're moving through the orchard, you're moving further and further back from the truck, okay, from the back of the truck as you're filling up that bed. So if you would just walk up to the truck and take the first 3 buckets you can grab, most likely those 3 buckets are going to be of a single part of the orchard, okay? Orchards are different. I mean, how they're grown, where the water flows when it rains, that's going to affect the growth of the apples. So you want to make sure you're getting all of the truck, because most likely all the parts of the truck are going to be from different parts of the orchard. So you want to make sure each piece is going to be represented. That's where the randomness is very important. You want to know how America feels about the sport of baseball. The sport has had some ups and downs, and you want to see if it is still America's pastime. You go to a Phillies game and ask people whether they still enjoy baseball or not. Okay? So I'm asking you, is this going to be a good sample for what we're looking at? Okay? Is it a good sample for this study? The study wants to see how America feels. Okay? Think about where we're getting our sample from. We're getting it from a baseball game. Most likely, if you were at a baseball game, you have some kind of liking of the baseball game, some aspect of it. It might even just be the social amount of it, but if you're at a baseball game and you're asked, how do you like baseball? Most likely those people are going to be saying they enjoy it. Okay? This would not be a good sample. Okay? There's going to be bias to that. Most of those people are going to be already fans of baseball, and that most likely does not represent the true America, how America truly feels about it. There's probably a lot more people who aren't going to those games that should be a part of our survey. Okay? They should be a part of it. So you have to think, where's our sample coming from, and who are we asking about it? Okay? And this is where sampling bias can come into play. Now there's a couple things about bias. One, it's systematically overrepresenting certain segments of the population and underrepresenting other segments. Like that baseball example, okay? We're actually representing the people who are already fans of baseball, that we know they are fans of baseball. So our percentage of people who still think it's America's pastime is probably going to be higher than what it actually is. And that's what you should talk about when you're talking about these biases. What direction is the bias in? In that case, it inflated our estimate of people thinking it is still America's pastime. Okay? Now, things that can affect this. Hey, how can this happen? Well, 2 types of sampling can have bias in it. Okay? One of those types is convenience sample. You use the observation units that are easiest to get to. Okay? A lot of times this would be, I'm a high school teacher. If I need students to take a sample, I may send a teenager down to the cafeteria during lunch and say, randomly pick me 10 students. Well, if you can think about how teenagers are going to act when they get to the cafeteria, who do you think they're going to go to? Okay? Do you think they're going to somehow find a way to randomly pick 10 people, or are they going to go to their friends, people that they know? Okay? That's going to be control some bias there, or contribute some bias. Okay? Because usually friends, they're friends for a reason. They have like minds, like decisions there. So it's not going to be a good representation of the population. It's going to represent that group of people. So that's over-representing your friends and the way you guys are thinking. Another one is voluntary response. This is where the observational units decide if they want to be a part of the survey, be a part of the study. This happens when online, when those surveys pop up, you decide if you want to take it or not. If you're reading through a magazine, those surveys that fall out of the magazine, you decide if you want to take the time to fill out that survey and make it to the mailbox to mail it then. Okay? So usually people are not take the time to do this. They have strong feelings about that topic. Okay? And usually those strong feelings, they're pretty hard-nosed on that feeling and on that direction. Okay? And that can be an issue for voluntary response. Okay? Ann Lairs writes a help column for a magazine, and she has those write-in polls, those polls where she says, please give me your opinion on these questions. Well, one question was, would you have kids again? 10,000 responses and 70% said no. Okay? You would think, okay, 10,000 responses is pretty high, 70% saying no. I'm gonna think many people who have kids would not do that again, would not have kids again. Now you have to be careful. People chose to take this survey. This was not a random sample. They decided, okay, I'm going to write this in. Because it ends up, that was only 2.5% of the population. Okay? And there's a good chance that 2.5% felt fairly strongly about not having kids again. And I can't tell you why, okay? The exact reason why, but there's a chance that that 70%, they don't want to have kids again because they went through a hard time with their kid. Maybe there was a tragedy and they don't want to go through that again. There was just a falling out and the heartbreak they had from that, they didn't want to go through that again. But a lot of time, but there's a good chance that people who have a good relationship with their kids, they're not taking the time to fill it out because that's kind of just a part of their life. Okay? It's not a lingering feeling that you would have if you don't have a good relationship with your kids. So most likely that 70% is probably higher. Okay? It's probably a higher percentage than actually is true. So that was an example of a sampling bias. Now, non-sampling bias or a non-sampling error, okay, this would be from non-responses. Okay? In this course, we're not going to focus too much on this, but I do want to say it one time. These people are the people who are correctly selected to be part of your sample. We have our sample, it represents the population, but the problem is people aren't answering our survey. This happens a lot in long-term studies when you have studies that are going for years and years. Okay? Well, those studies going for a year, people move away. Okay? People decide, okay, I don't have time for this study anymore. I can't keep answering these questions. I can't keep getting surveyed, tested, things like that. Your sample is good, but without all those responses, it might not be a valid sample anymore without getting responses from every observational unit. Okay? So sampling errors is when your sample does not represent the population. A non-sampling error, non-sampling bias, this is when your sample is good, but unfortunately, for whatever reason, we're not getting the answers we need to answer some of our questions to get some useful data. Okay? So that's the first part of 1.3. Okay? It's a little long, so I'm going to split this one into two parts. Take some time, take a break, and then go on to the next section of 1.3b.